In Chapter 7, we looked at the inverse of a function, and we saw that not all functions had inverses. In fact, only functions that were one-to-one and onto, meaning there was a one-to-one correspondence, only those functions had inverses. But there's a more general term of the idea of inverse dealing with relations, and every relation has an inverse. The inverse of a relation says that if you have a relation going from A to B that's a relation, the inverse relation goes from B to A. In other words, just like before, it's switching the domain and the codomain around. So if we have an ordered pair xy that's an element of the relation, putting the ordered pair yx is going to be an element of the inverse relation. For example, suppose we have a relation that goes from this domain that has A, B, and C in it, and this codomain that has 1, 2, and 3 in it. A maps to 1, A maps to 2, B maps to 3, C maps to 2. So this relation is made up of the ordered pairs containing the ordered pairs A1, A, 2, B, 3, and C, 2. When we make up the inverse relation, we're simply going from this is the domain to this as the codomain, and what it's going to do is it's going to take each ordered pair and flip the order. So A, 1 becomes 1, A. A, 2 becomes 2, A. This one becomes 3, B, and this one becomes 2, C. So it's pretty easy to make an inverse relation with a finite set. How about when we have an infinite relation? Suppose we do this one, where we have all the xy's in the Cartesian coordinate system, and we're going to say x is going to ry if the y value is equal to the absolute value of x. So some of the things that are going to be in here will be things like 1, 1, 2, 2, 1, -1. Sorry. If I put an x of 1 in, that won't do it. We need -1, 1, -2, 2. So in other words, if we graphed all of these, it would look like this. When we do the inverse relation, we're basically switching the x and y values. So we're going to be getting a relation that looks like this. Another way to think of this, it kind of goes along with what we saw about inverses of functions, is if you take the identity function and flip this over the identity function, what you're getting is the inverse relation.